What if, instead of stacking dozens of simple activation functions, you could capture complex feature interactions with a single matrix exponential? This paper introduces the M-layer, a fundamentally different approach to nonlinearity in neural networks. Let's start by understanding what motivated this work. Building on that motivation, conventional deep networks face several key challenges. They stack one-dimensional nonlinearities like ReLU repeatedly, which means you need many layers and parameters to capture intricate feature dependencies or periodic patterns. So what's the alternative the authors propose? Expanding on this idea, the M-layer builds an input-dependent matrix and exponentiates it. Trainable tensors project the input into a latent space, construct the matrix, and then extract outputs from the exponential, all computed efficiently using standard numerical techniques. What makes this powerful is its expressiveness. The architecture can encode any multivariate polynomial by exploiting the structure of nilpotent matrices, and it naturally handles periodicities using antisymmetric blocks that generate sine and cosine terms in the exponential. Comparing the two approaches highlights the key contrast. While traditional networks rely on depth and implicit modeling, the M-layer achieves comparable or superior expressiveness with fewer parameters and a transparent mathematical form. Following from this structure, the M-layer offers something rare in deep learning: provable robustness. Its explicit analytical form allows researchers to derive Lipschitz constants and bound the model's sensitivity to input perturbations directly. Looking at the broader picture, this work connects group theory to practical machine learning and excels at extrapolation tasks. However, choosing the right matrix dimension involves trading off expressiveness against computational cost, and numerical stability requires attention during implementation. The M-layer redefines what a neural network layer can be, replacing compositional depth with a single, mathematically rich transformation that is both powerful and interpretable. Visit emergentmind.com to explore more about this innovative architecture.